Ready to put it. Would you put it there? Alright, we have another question on the board. It says the figure below shows a body S of weight W hanging vertically by a thread tied at L to the string KLM. KLM is a string, and a body of weight W, the body is S, but the weight is W, is connected vertically to this string KLM. So this is the body acting this way. And they say we should find the tension along KL, the tension along the component KL, if the system is in equilibrium. Now, the word equilibrium there means it is balanced. This is a balanced system of forces. Now, we are told that there is a tension force acting along the component KL. How do we solve to obtain that value KL? Let's look at this. First things first, we'll do the resolution of the force M. So this is what we're having on the vertical and on the horizontal. This is positive y axis, and the negative y axis. And over here you're having the positive x axis and the negative x axis. And then we have a force M. We can call this force tension T. Since this is point L, tension TLM. Yes, this point is M. This point here is point M. This point is M. Okay, it moves to this point. So we can call this force TLM. That's the tension force acting along this component. Okay, the tension force acting along this component is TLM. Alright, and what else do you have to say there? The angle of inclination was 30 degrees towards the horizontal. Now resolve this force horizontally and vertically. Resolving it vertically and horizontally, you will be having to the horizontal component, this will be TLM cos 30 degrees, and to the vertical component, you'll be having this TLM sine 30 degrees. So since it is going upwards, it's positive. And then since it's coming this way towards the right, it is positive x and positive y. Okay, and there is a tension force acting along this component. We call it tension TKL. That's what we are told to find. Find the tension in KL. So tension force acting along this component, we call it TKL, going this way towards the negative x axis. And there is also a body S acting vertically downwards. So the weight of the body is acting vertically downwards. That weight is W, and weight is equals to mass times acceleration due to gravity. Yes. The weight of the body is mass times acceleration due to gravity. So in essence, if a body has a mass of 2 kg, for instance, has a mass of 2 kg, the acceleration due to gravity is a constant, which is 10 meters per second square. G. 10 meters per second square. You know, its actual value is 9.8 meters per second square, but it was approximated to 10, to the nearest whole number. Okay, that's it by the way. Now, the weight of the body is the mass times acceleration due to gravity, which is 2 kg multiplied by 10 meters per second square. The weight of the body now becomes what? 20 Newton. Okay, so its weight is 20 Newton. That's 2 times 10, that gives us 20 Newton. Alright, so we should know that the weight of the body is the mass of the body times acceleration due to gravity. Now we're going to take the we're going to take the summation of forces acting on the x-axis. The summation of forces acting on the x-axis. So summation of forces on the x-axis. Summation of forces on the x-axis now is sigma fx equal to, this is going this way, to the positive TLM tension along group LM equals 30, and this one going this way will be negative plus minus TKL. So plus and minus is minus, so this is TLM equals 30 degrees minus TKL. So cos 30 cos 30 cos 30 is 0.866. So that will be TLM times 0.866 and 0.866 minus TKL minus TKL. So you multiply this, sigma fx becomes 0.866 TLM minus TKL, which you can call equation 1. You can call this equation 1. Now we are going to look at the summation of forces on the y-axis. The summation of forces acting on the y-axis. So we're going to take this component going upwards, and we'll take this component coming downwards. So this now will be summation of forces on the y-axis. Summation of forces on the y-axis now becomes sigma fy will be equal to, okay, this one going upwards is TLM sine 30 degrees. It's going upwards, so it is positive y. The one coming downwards will be negative. That is plus minus W. Yes, the weight is coming downwards, so it is negative. Vertically downwards, so it's negative. So this now is this is TLM sine 30 is 0.5 plus times minus is minus W. So this is 0.5 TLM minus W is what? Mass times acceleration due to gravity, which is mg. So we can call this sigma fy. Sigma fy is 0.5 mg. Call it equation 2. 0.5 TLM minus mg, which you can call equation 2. Now at this point, we are going to take equilibrium conditions. Alright, we will then take equilibrium conditions. The equilibrium conditions are sigma fx is equals to 0 and sigma fy equals to 0. These are the equilibrium conditions. Equilibrium conditions. These conditions must be observed to ensure that the system is balanced. Balanced system of forces. Or you call them the static equilibrium conditions. Now we apply this to equation 1. You see from equation 1, you'll be having equation 1, you'll be having equation 1, we have that sigma fx is equals to 0, which is equal to 0.866 TLM minus TKL. Now this component is 0, so this is 0 equals to 0.866 TLM minus TKL. You can make TKL the subject of formula. It is negative here. Once it crosses over the equality sign to this component, it becomes positive. Now once you collect like terms, this negative crosses over this equality sign, it becomes positive. This is TKL equals to 0.866 TLM, which you can call equation 3. We call this equation 3. Alright, apply it to equation 2. Apply this to equation 2. You say from equation 2. From equation 2, you have that sigma fy is equals to 0, which is equal to 0.5 TLM minus mg, such that 0 will be equals to 0.5 TLM minus mg. Now if you take mg over to this place, you'll be having that minus mg crosses the equality sign, it changes to plus mg. The negative sign changes to positive the moment it crosses this equality sign and it comes over to the left hand side. Now this becomes mg equal to 0.5 TLM. And divide both sides by the coefficient of TLM. The coefficient of TLM is 0.5. So this becomes what? TLM equals to mg divided by 0.5. Okay? Mg divided by 0.5. So how do you further simplify this? You must look critically at this fraction. See that this is an unknown and this is a decimal number. So to further simplify, this becomes what? 1 over 0.5 times mg. And 0.5 is the same thing as half, isn't it? It's half. So if you say 1 over half, that is the reciprocal of half, is what? 2. The reciprocal of half, or the multiplicative inverse of half, is 2. So that means that this TLM is equals to 2mg. Okay? It's 2mg. Alright, you can call this equation 3. You call it equation 4, rather. So the value of the tension along LM is 2 times the weight of the body S. Or 2 times, of course, mg is mass and acceleration to gravity, which is the weight. Now the tension along LM, the component LM, is 2 times mg. Now put this component or this value into equation 3. Our bone of contention, our area of focus, is tension along KL. Now if you take this component 2mg and put it here, that is substitution. You substitute this value into this equation. You say substitute 4 into 3. Substitute 4 into equation 3. And you'll be having substitute 4 into equation 3. You'll be having, this is equation 3. Equation 3 is TKL equal to 0.866 multiplied by, in place of TLM, you write 2mg multiplied by 2mg. So this times 2, 0.866 times 2 will give us 0.862. Using your calculator, 0.866 times 2 gives us 1.732. Gives us 1.732 mg. 1.732 mg in newtons. Alright. This is the tension in KL. Tension in KL is 1.732 mg. 1.732 mg. Alright, thank you very much. At this point, we have come to the end of this educative program on Mathematics Made Easy. Please do not forget to like and also to subscribe for more videos. Just click on the notification bell, you will receive more educative videos like this. Also, don't forget to share and also drop your comments in the comment section. Thank you.